Recording has started. Okay, again, just to re-emphasize for the recording here, we've got two main topics for today. Number lines in data sufficiency continued from last time, and then data sufficiency problems involving angles. So as usual, we have to start with the normal content warnings, etc. I think the overall quality of the submissions as far as these rules go has been increasing, but people have still been posting things in violation of the rules, so be careful. Don't submit problems that are too general. In other words, if you submit something that is basically an entire area of the test, we can't really use that. So if you say, how do I do geometry problems? Great, but we can't cover all of geometry in 1 hour and a half. So please be a little bit more specific with that. Also, how do I solve problems faster? That's basically the entire test at once. So not acceptable for a study hall. Too specific, the other end of the spectrum, because we do have a forum. The purpose of the forum is to answer very, very specific questions about things. So if you have a problem where it's just, here's this one question and I want to know what's the difference between choices A and B, forums. Finally, don't submit personal issues. We had a couple people this week. We had about 3 or 4 people submitting personal study plan issues this week. Like, this is my score, and I want to know if I can get to this score by this point. It totally, I mean, that's not the study hall is not the place for that. Because remember that these are recordings that are watched by hundreds and hundreds, if not thousands of people. So we don't want to discuss personal study plans because that would have no value for anybody but the person submitting the study plan. So we have a place for those. It's the general folder on the forums. It's not here. Okay. We do want to see intermediate level topics. If you submit something really specific, please tie it into a more general question. So it's okay if you post something specific as long as it gives rise to some sort of theme that you can ask us about. Because if it were just a specific one question, we would just boot it over to the forum. Also, you got to tell us where the problem is from and no OG. People are still submitting OG problems. Do not submit OG problems. We are not allowed to use them. Thank you. Also, please, we've done about 30 study hall sessions by now. So please check the archives for sessions. About 50% of the submissions this week were for topics that we have already covered in the study hall. So I think people are not checking the archives. Like, I think people are just not looking at what was covered in previous sessions. So please check the archives before you post. There have been close to 30 study hall sessions so far. So, for example, we had somebody submit, could you please talk about find the assumption questions in critical reasoning? Well, we did. It's on March 4th. We had one person ask about main idea questions in critical reasoning, which we actually just did last week. So, a bunch of questions about stuff that has been covered already. What we don't really want to do in this study hall is repeat the same material over and over again, so please check to make sure that your topic has not already been covered before you submit it. Okay, these examples, you've seen them in other recordings, but these are some examples of the kinds of things you don't want to submit. These are too specific. This is the kind of stuff that belongs on a forum because the submitters do not tie these things into a more general theme. So these are exactly the same. These things are exactly the reason why we have a forum. So please post them there. Personal study plans. Here's my GMAT score. Here's my attempt. I don't know what to do. Guide me. We have the general folder for that on the forum. The study hall is not the place for personal study plans, given that hundreds of people are going to be watching it. Way too general. I mean, these are entire sections of the test. A couple of these are literally the whole test at once. there's nowhere we can go with these. These don't help us come up with ideas for the study hall. And then finally, OG, do not post OG questions. Really, guys, don't do it. Every week we have about 6 to 8 people submitting official guide questions, and we have to ignore them. Some people even type the entire question out, which is unfortunately just kind of a waste of time because we can't do that here. We can't do official guide questions in the study hall because that's a copyright issue. GMAT prep questions, those are okay because those are freely distributed software. OG questions, not okay. All right, study hall, if you're, smiley face if you're okay with these rules. Give me a smiley face icon over there if all of this makes sense to you, and we will proceed to the number line problems. Okay, so we are going to pick up where we left off with the number lines, and then we will go to angle problems. Okay, remember, here's how problems work. If you haven't attended these study halls in the past, I'll give you a quick I'm going to enable the multiple choice options. Then, okay, so you should see these options, these multiple choice options. You should see them, these right here. You should see multiple choice options like these. Should look, I don't know if it'll look exactly the same on your screen. I have a Mac. If you have a PC, it might look different. But you should see multiple choice options. When problems are posted, use these options to answer the problems. Please do not post your answers in the text box. Because then the whole crowd is going to see it. We want to make sure everyone is answering the questions on their own. If you click on these options, I've hidden your responses from other users, so they're not going to see what you're picking. So that's the purpose of that. Okay, everybody okay with this smiley face? If you see these options, if you know where to pick your answer to the question, smiley face if you see that. Okay, so let's take a look. Here's the first problem. There'll be a timer with about 2 minutes on it. Go ahead. Okay, that's the 2-minute mark. So if you have not chosen an answer, please do in the next 10 seconds or so. Remember, I can't make you guys pick answers, but this is a test where you are not allowed to proceed to the next question until you have chosen an option of the current question. So you got to guess. If you don't guess, you're doing yourself a disservice as far as the actual exam is concerned. So please pick an answer. There are 4 of you. There's 49er, Kashif, and Michelle. I guess 2 of you now. Please pick an answer, even if it's a random guess. Okay, still 1 person who hasn't picked an answer yet. All right, here are the answers from the class. Oh, someone changed. Okay, someone changed their answer. All right, here's what we've got. Somebody just signed in. The 3 responses of nothing here, one of them is mine, one of them is someone who just signed in. If you are the individual who didn't answer the question, again, make sure that you understand what we're saying about not answering questions. I mean, when you're in practice, you have to get used to the idea of responding to everything, even if you're not sure, because that's what the test makes you do. So, all right, let's talk about this. Give me about 5 seconds here. Okay, Let's take a look at this problem. There's a lot of dissent here. No more than 5 out of 15 people pick the same choice. But let's take a look. And remember the emphasis, as always, the emphasis when we study quant is on takeaways. What I mean by takeaways are lessons that can be applied. Remember, do not ever forget that this is the primary emphasis of any time that you ever study. Lessons that could conceivably apply to future problems. Because remember, this problem itself, you're not going to see this problem again, and you're not going to see anything that looks terribly like it. So anything you learn that is valuable is going to have this sort of form. If I see something on future problems, I should something. Make sure that you learn lessons that are of this form. Forward-looking, things that I might see again on problems that don't look exactly like this one. So let's keep that in mind. One thing about this, it's a visual problem. I mean, number lines are visual, right? But it doesn't have a diagram. If I see a highly visual problem that doesn't have a diagram, what do you think that means in the text box? Why would they not draw a diagram in a problem that is highly visual? Okay, you got people in the text box are saying you have to draw it yourself. Yeah, okay, true. But it's more specific than that. If it's a problem that clearly involves a diagram and they decide not to draw one, there's usually a more specific reason than that. You guys are getting okay. Suzanne Chu is saying it. With all possible scenarios. In other words, yeah, this is the big deal. If I see a visual problem without a diagram, I should be aware that there could be multiple situations. This is it. I mean, because there are lots of problems with diagrams. And I mean, this is a test where, honestly, on this test, the one thing that they really, really try not to do is waste your time. I mean, that's one thing you will probably find to be true. No matter how much you might hate this test, you will probably find that that's the case. They really don't waste your time. I mean, kind of a profound statement there. Like, the problems are hard, they're clever, they're tricky, they're unusual, they're unconventional. There's lots of adjectives we could use to describe these problems. But the problems are not busy work. For the most part, they will not make you render a diagram of something. Like, they're not going to do what high school textbooks often do and give you this excruciatingly specific visual description and then make you draw it. Instead, there's usually a reason, and the reason is usually this. If they don't give you a diagram, the reason they're not giving you a diagram is the vast majority of the time because there are multiple ways in which you can render the diagram. So let's take a look. The distance between point A and point C is 5. These are just distances. And the distance between point B and point C is 20. How could we have multiple situations here in the text box? Tell me how we could render this diagram in different ways. Yeah, okay. So the responses in the text box are starting to get to the point, which is the points could be in any order we want them to be in. We don't know the order of the points. So there you go. So we do know that C is the common sort of hinge here. They're both related to C. And we know that B is farther away from C than A is. But let's draw all the possibilities. So let's put C in the middle, because C is the one that's related to both of them. And then A or B, we have the distances are fixed, but we have this freedom of placement where they could be either on the left or on the right. So A is closer. You could put A on the right, or you could put A on the left. And then B is farther away, but B could be on the right, or B could be on the left. So there's our 4 possibilities. I mean, you don't need to be excruciatingly elaborate in drawing this stuff, as long as it's represented schematically in an accurate way. Like, in other words, as long as relative quantities are not too distorted. Like we definitely need B to be farther away than A, because the distance 20 is greater than 5. But here's our 4 possibilities. So the distance between point A and point B is 25. Well, let's find the distance between point A and point B. In these two, it's the short distance. In these two, it's the whole thing. So let's look at the distance between point A and B in those cases. Well, in this case, it's only 15. It's 20 minus 5. In this case, it's 25. In this case, it's 25. But in this case, it's 15 again. Smiley face if you guys see where the 15s and the 25s are coming from. And other face if you don't. If anybody gives the other face, we'll explain that a little bit more. Okay, all good. So statement 1 means you are looking at one of these 2 cases, because those are the 2 cases where the distance is 25. In both of those cases, point C is between point A and point B. Remember, don't forget to answer the question. I mean, just because we have 2 cases doesn't mean insufficient, because this is the question. And in these 2 cases, the answer to that question is absolutely yes. So in both cases, yes, C is between A and B. So that's sufficient. Point A lies to the left of point B. Statement 2. That is true in this case, and is also true in this case. In one of those cases, C is not between A and B. In the other case, it is. So we don't know. It's yes in one case and no in the other. So that's insufficient. Okay. So the answer overall to the question is A, which is the plurality answer. It's the one that more people picked than any other choice, but definitely not a majority. That's 5 out of really 13 people, not 15. So still not a majority. So I guess this problem is pretty tough for the crowd in general. But the takeaway, this most important thing you can learn, remember, you have to look forward from these problems. You have to resist the temptation to just solve the problem and be like, hey, I solved the problem, because that doesn't have value. There's no value in just solving the problem. You've got to look forward to possible future consequences in problems that don't look exactly like this one. This is one such consequence right here. Any questions about this problem? Type in the text box. Otherwise, we will move on to another problem. Okay. No questions. All right, let's move on. Remember that you should someone says in the text box, how about combining both statements? Does anybody have an answer to that? There's a definite answer to that. Does anybody know what it is? And while people are typing, let me comment that this question, the question indicates that the person asking the question is still unfamiliar with the basic setup of data sufficiency. Yeah, there it is in the text box. You don't put the statements together unless they're both insufficient. Because if one of the statements, if either of the statements is good enough by itself, there's no need to put them together. You wouldn't figure out anything by doing that. So if you, the asker of the question, make sure you go back to your basic treatment of data sufficiency. If you have our materials, watch the recording of class session number 1 where we talk about this, and then, or look in the front of the data sufficiency chapter of the OG. So the student asking about difficulty level, when you study, you should not really think about difficulty levels of problems. They're pretty much irrelevant to your study. Because remember, the point is not solving the problems. The point is discovering principles that will apply to future problems. And these principles transcend the whole issue of how hard the problem is. I mean, this lesson is relevant no matter how hard or easy the problem at hand is. So by even thinking about difficulty levels, you are just limiting the way that you study. You're going to get less out of your study if you're thinking about that kind of thing. So the answer is irrelevant. Okay, let's take a look at another one. Let's try this one right here. Okay, again, please use your polling buttons, your multiple choice options. A bunch of you have just shown up. So since you have, let me just show you this screen again that we just saw. This one. Okay, you should see these options on your screen. There's about 6 people that weren't here for the first problem, so sorry for the redundancy. You'll see these in the corner of your screen. These are what you should use to answer the question, not the text box. Please do not type answers in the text box. Thank you. Okay, here's the problem. Right here. Okay, I'll give you a timer again. About 2 minutes. Go for it. Okay, let's try to answer in the next 10, 15 seconds. Remember, if you weren't here to hear this little admonishment the first time, you got to answer everything because that's how the test works. The test doesn't let you abstain, and the test doesn't let you skip questions. So you got to get used to just picking an answer. There's 3 of you who don't have answers. Please pick one. There's a JM, there's a Sam, and then there's an SN Misra. 5 seconds, please guess something. Okay, so you guys still aren't guessing. Remember, I mean, you know, you're on the other end of the internet. I can't make you pick an answer, but remember that you got to pick answers to everything. That's how this test works. So, okay, here's what people did. If x is a positive number less than 10, then is z greater than the average of x and 10? Okay, let's discuss. You might be tempted to just throw this into an algebra form right away. You might. I mean, we'll look at that in a second. But let's take a look at this visually. Because, I mean, remember, you want to try to get as many interpretations of these kinds of things as you can. Let's consider this visually, because the problem involves number lines. In other words, you want to take the clues from the problem at hand. There's going to be different ways of interpreting stuff. Like if I asked you, is z greater than this average, and you know, you've got something like a bunch of equations written out, then you're probably going to take an algebra approach to the problem. But we've got a number line here. So because the problem involves a number line, it's a good idea to take an overall visual-based approach to the first part of the problem. So there's a takeaway here. There's a lesson that you can learn just from that, which is when there are multiple ways to approach something, you should look for clues in the surrounding environment of the problem to guide your choice. Because you can think of averages visually, or you can think of them in terms of crazy algebra equations. But look around, see what you're looking at. So here's what this looks like visually. Here's a number line. Is z greater than the average of x and 10? So we know x is some positive number, so let's go ahead and put 0 on this number line as well. So here's 0, x is some positive, and it's before 10. So these things are definitely in this order. There's no multiple orders. Question in the text box, how do you draw that blue thing? How do you draw the average of x and 10 on the number line? Like, where is that located? There you go, guys. It's the halfway point. So this is also a takeaway that you can get if you don't have it already, if you don't already know this. The midpoint is the average. There's no difference at all between an average and a midpoint. So is z to the right of that midpoint between x and 10? And so the region where we're looking is we want to know whether z is over here. Smiley face if that makes sense from a visual standpoint. One or two of you are typing algebra into the box, but not what we're talking about right now. We're talking about a purely visual approach to this problem. So the question is z over here? So, well, number one, the great thing about this is that is exactly what number one says. Z is closer to 10 than it is to x. Well, if you think about which points are closer to 10, it's exactly those points. So, statement one, the points that are closer to 10 than to x are exactly the points that are to the right of this midpoint. This is a general takeaway also if you need it. Like if you have an x and a y, then the points that are closer to x than to y are the ones that are on x's side of some midpoint. In fact, you can even do this in 2 dimensions. Remember, in the interest of whenever you look at concepts like this, you should try to generalize the concept as much as you can. So like in two-dimensional space, it's not relevant to this problem, but this is the kind of way you need to think about these things, because in the next problem it might show up in some analogous situation. So in a two-dimensional situation, let's say this is point X, and this is point Y. Let me put some letters on there. Let's make those dots a little bit bigger too. Let's make that point X, and let's make that point Y. It's not a box. It's a roping off the corner. Yeah, you're only going to see two sides of it. Okay. This is Y. This is X. Who can describe in the text box where are the points closer to X than Y? What would that look like? It's not going to be a circle. Circle would be if you gave some fixed distance away from X. Like if I said, points that are less than, I don't know, 6 units away from X. That would be a circle. Yeah, suit-on shoe is getting there. You're less than half the distance between X and Y. Not necessarily, Nicole, because you could have points that are way on the other side of X that'll be farther away than that from anything. But yeah, suit-on shoe's got it right. There's a line which is, I'm going to draw it in two parts just to make sure I draw it accurately. It's going to look like that, which divides the 2 points up. It's called a perpendicular bisector if you like terminology. If any of you know American football, the best way to think about this line, if you know American football, it's very easy to think about this line. Just imagine that X and Y are linemen on the opposing teams, then this is the line of scrimmage between the two teams. Like if you imagine having other football players lined up right here. And that's why football is set up the way it is. All the points over here are closer to Y, and all the points over here are closer to X. So the points that, if you like to get technical, then the actual definition of that line is that if you take this line between X and Y, then it's perpendicular to it, and it also cuts it in half. It's called a perpendicular bisector. But visually speaking, it's just like a line of scrimmage on a football field or other such thing. So if you look at that, then the points that are closer to X are the points that are all the points that are on X's side of that line. And that even includes the points that are, thousands of miles to the left. It's everything on that side of that line. So there's an analogous situation. When you review problems, you should make an effort to try to think thoughts like these. Try to think of how could I generalize this concept? What other ways could I see the same sort of thing? Okay. So back to statement one. Statement one is telling you that Z is over there, because the points that are to the right of this line are exactly the points that we're talking about. So this is sufficient, because statement one is telling us that Z is to the right of that line. Smiling face if that makes sense. And we'll take an algebraic approach to this problem in a short bit, but visually it's immediate. So this goes to show you the power of having multiple ways to approach a problem. Statement 2, Z is 5x. Well, let's take a look at different cases here, because remember that X could be anything between 0 and 10. So let's look at extremes. So if x is, let's say, 0.1, then z is just 0.5. So here's our number line. If we try to draw a somewhat accurate rendition of this, then here's what we're looking at. Here's 0, here's x, here's z, and here's 10. So let's label those with appropriately tiny print. That's 0, that's x, which is 0.1. That's z, which is 0.5. And that's 10. This is going to be a no to the question because the halfway point is going to be like all the way over here somewhere. So your region of interest is over there. And z is not in the region. So this is a no to the question for x is 0.1. On the other hand, if x is something like, okay, I'm going to mention something, which is that, remember, the two statements are never allowed to contradict each other. If you know that, then actually you're done, because the answer to this was yes all the time, the answer to this other statement. So since that was all yeses, this can't be all no's. If you make that realization, then you know there must be some yes possibility somewhere, which would make this insufficient, and you actually don't have to do anything. If you don't make that realization, then just look at more cases of x, except look at more extreme cases of x. So if x is like 9, then z is 45. Okay, I don't think we need to draw this picture. Z is definitely way to the right. So it'll be in that region. So that's a yes to the question. So insufficient. Any questions about this? Questions in the text box? The overall answer then would be A. Second most popular answer. A lot of people pick D on this one. Takeaway, there's a lesson here, which is this. You want to look at extreme cases. I mean, this is a very general thing you should try to do in lots and lots of situations anyway, but especially in number line situations. Most commonly, inequalities. Like, picking extremes is the single best way to approach inequality problems. And this is, if you think about it, sort of an inequality problem. I mean, this is definitely up here. This is definitely an inequality. I mean, it is, you know, restricting x to this range between 0 and 10. So this is an inequality. Okay, nobody's got any questions. I'll show you statement 2. There's not really a decently short algebraic way to do. Statement 1, you've also got to break into a couple of cases. So let me just do the point here is not algebra, the point is number line, so I want to make this a brief treatment, but I will mention it. So I'll briefly, without going off track too much, I'll give you an algebraic treatment of statement 1. Algebra treatment of statement 1. Okay. The question, there's a big question in the text box. I'll get that in a second. The question is, in algebra form, it's is z greater than the average of x and 10, which means x plus 10 divided by 2. Okay, and then we can play around with this inequality a little bit. I mean, there's various forms that it can take, but you're gonna have something like that. Okay, what you're going to have to do is you're going to have to look at two different cases. Case one is where Z is between X and 10. So in other words, a case that looks something like this. Because there's two ways of being closer to 10 than X. One way is to be between X and 10, which is probably what most people are visualizing. But then you also have to consider this. You also have to consider the case where Z is closer to 10 on the other side, like that. This is another one of those non-diagram problems. So in this situation, is 2Z greater than X plus 10? So let's draw this to scale here. This has to be the distance that I'm putting in orange highlight has to be bigger than the distance that I'm putting in blue highlight. That's important. That distance is greater than that distance. So 10 minus Z is greater than Z minus X, less than. So Z minus X is greater than 10 minus Z. If you rearrange this by adding Z and X to both sides, you will get exactly the inequality 2Z is greater than X plus 10. So that's a yes to the question. In case 2, you would prove that differently. You would just prove it by realizing that Z is bigger than 10, and Z is also bigger than X. So if I have Z plus Z, that must be bigger than X plus 10. Because the first Z is bigger than X, and the second Z is bigger than 10. So if I add two bigger things, then that's bigger than two smaller things. So that's also a yes to the question. So you get a yes no matter what, and that's sufficient. I mean, that's a lot harder, but it is algebra, and it does work. And I mean, at the end of the day, you just want as many legitimate approaches as you can have. So, okay. Any questions about the algebra approach? Let me look at this question in the text box and see what we're dealing with here. Any questions about the algebra approach that's on this page? Text box. Okay. The question in the text box says we are supposed to determine whether it solves the question. Well, yeah, but this doesn't solve it, because if you look at statement 2, we showed explicitly that it doesn't answer the question. Because if you've got statement 2, then here's one case under statement 2 where the answer to this question is yes, and here's another case where the answer is no. So we've just shown that it doesn't answer the question. You don't know whether it's yes or no. If you're thinking, there's a beginner's mistake that people make where people think that if you can, they're thinking even if it's yes or no, there's still some answer in each case. If you're thinking that way, you're going to magically get D to every single problem that you ever do. And then that should tell you that there's something wrong with that approach. So you have to get the same answer all the time to be called sufficient. This is two different outcomes. So this is insufficient. As someone asked, why two cases? Because there are two cases. So yeah. Sam, Z is 9 and X is 8 doesn't satisfy this. So that case is irrelevant. Because 9 is not closer to 10 than it is to 8. It's the same distance away. So that doesn't satisfy the statement. Question about why two cases. You need two cases because there are two cases. I mean, if z is on this side of 10, then this is 10 minus z. But if it's on that side of 10, you can't write 10 minus z anymore because that's a negative number. So like this work that we're doing here doesn't work for that case. And this work doesn't work for that case. Like you have to treat them differently. I mean, you can write some garbage with absolute values, but you wouldn't be able to reduce it. So in order to actually prove this, we need two cases. By the way, this is a really, really common thing. If you're going to do algebra with things like number lines or distances, you are going to have to split things up into cases a lot. So be ready for that. My main point here, though, is this visual approach, which makes number one soluble almost instantly. So there you go. Any other questions about this bad boy? Otherwise, we'll move on to another one. Okay, try this one. This one's going to get interesting. Try that. Okay, you guys know the drill. There's answer buttons. Please use them. Here's a stopwatch. Love you all. 2 minutes, 18 seconds. Go for it. Hey, wow, the answers to this one are interesting. You will see what I mean in a second. Okay, there are a lot of you who have not yet picked answers. So in the next 20, 15 seconds, please do so. Let's see, there's a Gav who just logged in. Sam, you don't have an answer. And then there's one other person with tech problems. So, Sam, let's pick something. Okay. Remember, Sam, the GMAT doesn't let you not pick things. So, on the test, you got to just, guess. All right, here's the answer profile. And the popularly selected answer here is incorrect. The answer to this problem is not C. So let's take a look at it. The distance, okay, what is the value of R? So I think we can safely get through the first couple of options here pretty quickly. These are just distances. So by themselves, it's not going to give you anything. This won't fix any values. Nobody picked A, B, or D, so I'm assuming we can do this part pretty quickly. 12 is halfway between M and R. This just means that M and R are some 2 points with 12 as midpoint. This isn't going to give you not specific enough. So individually, they're not sufficient, so we got to put them together. All right. If you see something like this, if you think this just means that R is 3 times M, you got to watch it with that kind of thing. I mean, because remember, okay, these test writers are lazy. I mean, they're not going to exert too much effort to write things that don't need effort to write. So, like, if they're going to this kind of trouble, you should suspect that something is concealed by this wording. You should suspect that this weird phrasing is hiding some sort of secret. beyond just like, you know, R is 3M. I mean, there's always more to these problems than meets the eye. I mean, but let's just take a look. I mean, this problem is actually, and remember what we said, the main point of doing any sort of study is to connect problems that you've seen in the past with problems that you're seeing now. So you got to make associations when those associations are available. There's an association you can make here with this problem. I mean, it's almost, at the end of the day, it's almost exactly the same situation. Like here you had some distance relationship, but you didn't know which side these things were on, and so you had to sketch out the different possibilities. At the end of the day, this is actually the same thing. Because we don't know which side of 0 these things are on. So this is a lot like, it should remind you of that last problem. Should remind you of the A, B, C, 20 and 5 problem. If it doesn't, it means you, okay, if you didn't make that association, it means that you are thinking of these problems as separate entities all the time, which is not the way to think about this. You got to think about them as interrelated things, that it's the relationships between them that are most important. Because the same insight that you got there can totally help you here. So the distance between R and 0 is 3 times the distance between M and 0. So we got to sketch out 4 cases again. So number 1, 4 cases. Here they are. 0. Let's put 0 on there first. 1 case is where R and M are both negative. So that's R over there, and then M would be somewhere like here. The next case is where R is negative but M is positive. The next case is where M is negative but R is positive. And then the last case is where they're both positive. Okay. So there. Let me line those up a little bit better. Okay, that should look a little bit better now. Here's our cases. Also notice the ratios here are set. These are not random points to the left and right of 0. You have to have that 3-to-1 ratio. So, okay. 12 is halfway between M and R. So if we're putting these together, we need to think about in which of these cases, because we need both of these things to be true. So now we got to think about which of these cases will actually allow us to do that. So in which of these cases is this actually possible? Well, let's take a look. Halfway point, if you do this with algebra, it will take you a very long time. But if you do this visually, this halfway point is negative, so that case isn't going to work. This halfway point is also negative, so that case isn't going to work. This is positive, and this is positive. So we need this to be 12. So this case isn't going to work because that's negative. It can't be 12. And this case isn't going to work either because that's negative. It can't be 12. So if 12 is positive, well, 12 is definitely positive. I'm not really seeing the question. Maybe you could clarify the question. But 12 is definitely positive because it's 12. Okay, so these are the 2 cases that we want. Let's take a look. Well, this is 2 separate cases. So you can, if you have a visual sense of these numbers, then you don't have to do algebra. Because you can tell that, I mean, in this case, you can tell that R is a lot bigger than it is in this case. Because R here is, you know, substantially larger than 12, whereas R here is not. If you don't have that sort of visual intuition, so visual intuition, you can skip out on the work by just saying that the value of R in the first picture is a lot bigger than 12. But the value of R in the second picture is closer to 12. So that's insufficient. There's two different values. If not, let's just work out the algebra. So in the case of algebra, let's call this case 1. Let's call that case A, and let's call that case B. Okay. In case A, if you look at the picture, you'll notice that R is 3 times M. It's negative 3 times M. Because they're opposites. I mean, the distance there is 3 times, but it's also in the other direction. So R has to be negative 3 times M. So then your equation would say that 12 is the average of M and R. So that means that 12 is M plus R divided by 2. Substitute negative 3M for R. So that will give you M plus minus 3M. So M is negative 12, which means R is 36. If you solve case B, I'm not going to show all the work for case B because this is not an algebra session, but it's very similar to what we just did. The difference is that R is positive 3M instead of negative 3M. So if you look, you can see that R is positive 3M. If you do a similar process, you'll find that M is 6 and that R is 18. So 2 values, one of them is 36, one of them is 18. So that's still insufficient. And you've got yourselves E. Okay. The main takeaway that I want you to get from this whole thing, aside from all these little cool facts about number lines, the main takeaway that I want you to get is the relationship between the problems you have studied and the problems you are seeing. Okay, like you got to make the association between problems like this and problems like this. Very important. That's why you study. This is the whole point of studying, is to make associations. That's very important. So if you don't make associations, there's really not a lot of value in studying. You cannot memorize problems. Memorizing problems is actually worse than doing nothing. So be very careful with that. Any questions about this one? I see one gentleman typing in a text box. If any one of, I'm not really understanding the question. I think you might be asking me, what if the problem gave you restrictions on M and R, like if it restricted the signs of that. If that's what you mean, just look at these cases and figure it out yourself. If you ruled out one or the other of these cases, then you would get C. And if you didn't, if they're both still there, then you get E. So like if I tell you that R is positive, then you're still going to get E, because you still have both possibilities. But if I tell you that M is positive, in addition to all this stuff, then now it's just this one. So that would be C. And if I told you that M is negative, then you would have that one, and so on. So just look at the cases and see if they're still there. Okay, let's move on to the other topic that was promised. The other promised. Okay, someone's typing a question, so I'll wait until your question shows up. Why the case 1 is true. Distance is either way. The question is, I mean, look at these cases. Case 1 just means that this distance here has to be 3 times this distance here. You can, it's exactly like the other problem in the sense that those distances could be in any direction. So, I mean, you could write a statement like this with absolute values, but then there would be nowhere for you to go with that statement. But visually, we don't care which direction these things are in, as long as this distance to R is 3 times as much as this distance. Just as in this problem, we don't care which way we are going, as long as the distance from C to B is 20, and as long as the distance from C to A is 5. So if it's 20 this way and 5 the same way, we're good to go. But if it's 20 this way and 5 the other way, we're also good. This is exactly the same sort of thing. So it's very visual when you think about it this way. But you can't, the distance between R and 0 is not R. It's either R or negative R, depending on which way this thing goes. Okay, the other promised topic today was angles. So let's get to a couple of topics involving angles, and then before we are out of time. So try your hand at that. Yeah, go for it. Give you about, let's see, 218 again. Go for it. Okay. So you all had answers, although now 2 of your answers are gone. If you are one of the people who took your answer off, please put an answer on there because we are now out of time. There's one, Nicole, you had an answer on there, and now you don't. So, all right, here are the statistics. At least you all answered the question this time. That's a good start. As has been the case before, the most popular answer this time is not correct. But let's take a look. Let's resize this thing so that we can actually look at it. Okay. Let's talk about this problem. Let me point out a fact about the problem. The fact is that these angles have lots of relationships to each other. I mean, you've got the circle, you've got so the circle is going to give you, you've got a bunch of things that you're told are equal, and so on. You have AB is the same as OC, so let's put that into the diagram. That's a relationship. Who knows, okay, what is the circle doing in this picture? As a hint, it's pretty much the same thing that a circle will be doing about 90% of the time when it's in diagrams like this. Because if you think about it, the circle doesn't have much business here. I mean, this is a diagram about angles and triangles and stuff. So the circle is sort of, you know, what is it doing? Yeah, exactly. So first takeaway that you can get from this problem, if you see a circle mixed together with a bunch of lines and angles, not always, I mean, there are things like inscribed angles that might be happening, but in most cases, if you see a circle mixed in with lines and angles. Check carefully for equal radii, because all the radii of the circle have to have the same length. And so this will generate things like isosceles triangles. Okay, that's a useful takeaway. In this case, the circle makes these two radii the same. And that's actually all the circle does in this whole problem. I mean, as soon as you notice this, you're basically done with the circle. So now we know that all of those are the same. So A, B, BO, and OC are all the same. Here's the biggest takeaway from this problem, and let me just hand it to you. The most important takeaway that you can get here from this problem, and for angles in general, is when you have angles with relationships, you should define one variable if that's necessary, and then fill in as much of the diagram as possible before proceeding. This is really important. You want to fill in as much stuff as you can possibly fill in before you even touch those statements. So let me make a slightly bigger version of that diagram, because otherwise it's going to get messy real quick. So here, whoa, I didn't mean to do that. Okay. Here's a slightly bigger version of that diagram. Let's put an X, for no other reason, I mean, for lack of a better reason, let's define an X in the angle that we actually want, which is this. Because we got to put a variable somewhere, and I don't really see a good reason to put one anywhere else. So let's put one there. This is the angle that we want. Okay, someone already wrote in the text box, yeah, triangle ABO is isosceles because these are the same. So that means that angle BOA is also X. All right, so this is a triangle. As a corollary to this takeaway, usually you won't need to use anything except two things. Except 180 degrees in a triangle and 180 degrees in a straight line. There is this little trick called the exterior angle trick. You don't ever actually need that because you can always figure it out with triangles and straight lines. So if you know that trick, great. It'll save you like 5 seconds here and there, but it's not a super high priority. 180 degrees in a triangle, 180 degrees in a straight line. Well, this is a triangle, this green thing. So we have two angles of that. So we can fill in the third angle, which is 180 minus the other two. That's 180 minus 2x. Then this orange thing is a straight line. So this guy right here is 180 minus the green one, 180 minus 180 minus 2x. If you reduce that expression, that gives you 2x. Where do I go from there? Text box. Nobody. Okay. Yeah, this is another isosceles triangle. So that's going to be another 2x, which makes this 180 minus 4x. You got another triangle. This purple thing here is a triangle. So that's 180 minus the other two angles in that triangle, 180 minus 4x. Notice we haven't even touched the statements yet. That's the point. We can do all of this literally without touching the statements. Okay. And then this last angle, COD, that gives us this whole thing. This brown guy is a straight line. So you can just do 180 minus those other two angles. So 180 minus other two angles. So that's 180 minus x plus 180 minus 4x. That, if you, at the end of the day, that reduces to 3x if you do the algebra. Okay, hey, look at that. So this is the importance of this, because if you do this, a lot of the time you're going to find, I mean, yes, this is a rather large time investment up front, but again, remember, GMAT problems don't waste your time. So any problem, any method that requires a large time investment up front is generally going to require very little time investment afterward, and that's the secret here. Like as soon as, I mean, it's probably going to take most of the time you have for this problem to do this work. But as soon as you do that, you've got like literally nothing. You can answer these immediately. Because the question becomes, what is x? And, well, this means 3x is 60. So we have x. And this gives us a number for 2x. So that gives us x also. So these are both sufficient, and the answer is D. Major takeaway from the problem, super, super important. This. Fill in as much of that diagram as you can right off the top. Questions? Any questions about that? Okay. We can probably make time for one more of these angle problems. Let's do this one. Clear out your answers. I'll give you 218. Give you 225 or so for this one. Go for it. Okay. All right, ladies and gentlemen. I think everybody's got an answer. So this one's pretty good. Possibly the best overall class performance of the night. Let's take a look. Let me make that problem a little bit smaller so the polling results fit. Okay, here's your class results. Again, the non-responses are me and two people who are having tech problems. So that's good. You all answered the question. Okay, let's take a look. First of all, we want to make sure that we figure out what the question is. The question is, and we don't want to define two variables. That's the other big thing here. We do not want to define two variables. Two variables on most of these problems is the kiss of death. Let's just call things like this and that and avoid using variables for them until we define a variable. So PRS is this angle, this one right here. I don't want to make a variable for that yet, because I don't want to be overwhelmed with variables. This, and then that. Yeah. Question is, what is this minus that? That's the question. So You could just say PRS minus PQR, but for most people, that's sort of annoying. Like most people, PRS, PRQ, QPR, those things are not like you have to keep double and triple checking those things. Like it's just alphabet soup, and it's not very. Most people have to triple check things like QPR, PQR, PRQ, PRS, and RPS. Because they all get scrambled in your head. I mean, I'm dyslexic, so I'm a little bit hypersensitive to this, but it's not a good idea to keep all those angle letters in there. It's very confusing. So, and I mean, the stakes are too high, because if you confuse something like QPR with PQR even one time, that's going to be bad. All right. Let's take a look. You may not even have to use angle S, but let's take a look. QPR, let's make this diagram a little bit bigger. Let me blow it up. All right, here's the diagram. Statement 1 says QPR is 30. Let's make 2 diagrams. Stupid question, why am I making 2 diagrams? Nobody? Why am I making 2 diagrams? Yeah, that's good. There's 2 different statements. Some people don't make 2 diagrams. It's data sufficiency. You should make 2 diagrams. You really should. Because remember that because there's no eraser. I mean, if you're doing things like using erasers at home, by the way, then don't, because you don't get an eraser on the test. So one thing that's like a procedural takeaway then, it's not even a math lesson, it's just a procedural element, is you should make 2 diagrams when you have a geometry data sufficiency, unless the process is so transparent that you don't need to. Meaning, once we figured out the secret to this problem, the process was so clear that we didn't need to make more than 1 diagram, because we did this work beforehand. But if you're doing separate work, then you should make 2 diagrams. Also, remember from the previous slide, the most important takeaway about these kinds of problems is fill in as much of the diagram as possible, as soon as possible. Very, very super duper important. Okay. Okay. Statement 1, QPR is 30 degrees. That's this right here. So let's define a variable. Let's put the variable here. Then what is that angle? Text box. This angle here, which I guess would be angle QRP. This obtuse angle. What is that? You can type a whole expression into the box if you want. Yeah, it's 180 minus the other 2 angles. Good. So that reduces to what? Yeah. So this is, the work is 180 minus the other 2 angles. And that reduces to 150 minus x. 150 minus x. And then this angle, the angle labeled this is a straight line, so it's 180 take away the thing we just found. So minus 150 minus x. So that's 30 plus x. And then notice you don't have to find x. And in fact, in problems like this, if they ask a question like what's the difference between 2 angles, you should suspect that you will be able to find that difference without finding the angles. That's how these guys operate. Like, otherwise they wouldn't be bothering to ask you this question. Like, you know, if you could find the angle, they just ask you for the angle. But if they ask you what's the difference between two quantities, you probably can't find the quantities. But you probably can find the difference, which is what gives you that such weird question. You know, again, yeah, exterior angle, I mean, if you know the exterior angle rule, great, good for you. It'll save you 5 seconds. If you don't know it, it's really not a big deal. So, but if you do know it, it can be a shortcut. It is of very low importance, though, because it will not do anything that this kind of approach won't do. So, I'm making this point over and over again because some people on the forums have agonized over the exterior angle rule. You don't care. It's very low priority rule. Okay. Well, this minus that is 30 plus x minus x, and so that's 30. There you go. The other statement, that's sufficient. It's a hard number for the difference. We don't know x, but we don't care because we've got the difference. This one, if these two angles are 150, then that's two angles of a triangle. So you can find the third angle of the triangle. And that means the third angle has to be 30. 180 minus 50. And then once you figure that out, it's the same thing as statement 1. Because as soon as you figure out that that's 30, you now have exactly the same situation that you had over here. Because this is 30. As soon as we knew this was 30, we had everything else figured out. So same situation as statement 1, so that's sufficient. Questions? Text box. There's also a backup approach. I know we're basically pushing the time here, but let me show you how this works. I'll just show it to you for statement 1. As a backup, here's the basic description of this. And then I'm going to refer you to another study hall where I flesh this out a little bit more. But the backup method is plug in multiple values. And if you get the same answer over and over again, then that's sufficient. And if you get two different answers, then insufficient. For more I'll show you how it works on this problem. For more details, see the last part of the February 4th, 2010 study hall. But here's how it works. What we know, let's do this for statement 1. Remember, statement 2 winds up being the same as statement 1. So that means this angle is 30. This is statement 1. So what we're going to do is we're going to plug in different numbers for unknowns. And we need to try different values. So let's try kind of small print here. Let's make this, let's say, I don't know, 40 degrees. Then that would mean 30 and 40 is 110, 70. So this would be 110. And then this would be a 180 minus 110, which is 70. So in the purple values, my difference is 30. Answer is 70 minus 40 equals 30. Okay, let's try new values. Let's make that 1 degree. Then that would be 31, so this would be 149. And that would be 180 minus 149, which is 31. If I use those orange values, my answer is 31 minus 1. So I get the same answer. I mean, this is already looking like it's not a coincidence, but let's just try one more. Let's make that, I don't know, some other angle, like 13 degrees or something like that. Then that's lucky 13. Then that's 43, so 137. And 180 minus 137 is 43. So using the green values, I get 30 again. All right, I keep getting 30 over and over again. Like, this is, you know, it's going to keep happening. So, sufficient. All right, that's a backup method. It takes probably more time, but it works. And the advantage, like other backup methods, the advantage of it is that you don't have to understand anything about how the problem really works. That's what's cool about it. So, all right. If you want more information on that particular method, you can check out the study hall that I've quoted, which is February 4th edition. Otherwise, we're done. If you've got any quick administrative questions, I'll go ahead and answer them. Otherwise, the next edition will be on February, I want to say February 3rd at 7 Pacific, 10 Eastern. Not 7:30 like the last one. The last study hall was at 7:30, 10:30. But that was a special time. We're going back to the old time, which was 10 p.m. Eastern, 7 p.m. Pacific on the hour. Okay. Yeah, this method's not horribly time consuming. I mean, if I hadn't been talking the whole time, I could probably do all this in maybe 45 seconds. So it's not horrible. But again, remember, it's not a choice between this and like the other method. This is a backup. This is what you do if you don't know how the other method works. So it's false choice, false dichotomy to think of it as this versus the other method. You need to know both, so that if you don't understand the textbook approach, you still have something to use. It's a very bad way of thinking to try to figure out which method is the best all the time. Because the best way to do this is just to learn more approaches. You should learn as many approaches as you can get your hands on. Not try to make constant judgments and decisions about which one is best. I mean, you just want to find things that work so that you have more ammunition, basically, to throw at your opponent when you take the test. I mean, it's, you know, if you've got one method that you think is the best and I've got two methods, then I'm better off than you are. It's basically the way to think about it. So you don't want all this prejudice about whichever method is better or whatever is kind of a waste of time. Because remember, the problems, if you got a problem that looked just like this one, then those thoughts would have some validity. Like, then you would want to be thinking about better or worse, whatever. But you're only going to see vague resemblance. So the method that is better here might be worse on another problem. The method that is faster here might be slower on another problem, etc. So it's really all about just collecting methods. It's about being greedy and finding as many methods as you can find. Okay, let's kill it. If you have quick administrative questions, go ahead and type them. Otherwise, I will log you out. I'm going to kill the recording right now. Take it easy, guys. Next recording's in 2 weeks at 7 Pacific, 10 Eastern on February the 3rd, which would be sometime on February 4th if you're in the Eastern Hemisphere. Okay, night, good luck. Take it easy.